Okay, so today we're going to look at factoring a difference of two perfect squares and then also factoring perfect cubes. So we're going to start off with factoring a difference of two perfect squares. So if I look at an example like x squared minus 4, I know it's a quadratic. I can see it's a quadratic because of the x squared. So I know if it's a quadratic, there's a good chance it is going to factor into two binomials. I know that the first term of each binomial is going to have to be x and x, because that's how I would get my x squared. My second term of each binomial should multiply to give me the minus 4 and add to give me the middle term. In this case, I don't have a middle term. So it should multiply to a minus 4. Let's write that out. Multiply to a minus 4 and add to, well, nothing. So my only options are 4 and 1, negative 4, positive 1, positive 4, negative 1, or negative 2 and 2. Negative 2 and 2 will work, and I can check it by foiling it out. Still get the second one. So again, it's a quadratic. I know it's a quadratic because of the x squared. It means it's probably going to factor into two binomials. My first term is going to be x and x. And again, I need to find things that multiply to a minus 9, negative 9, and add to nothing. Again, I don't have a middle term, so nothing. In this case, minus 3 and plus 3. This is why it's important that it's the difference of two perfect squares. Difference means minus, so it means subtraction. They need to be subtracted, so that way I can get the opposite signs. If they weren't subtracted, if they were added, I would have to have a positive 2 and a positive 2, which would not cancel out. So they wouldn't add up to 0. So it has to be a difference so I can get the opposite signs, and then perfect squares so I can have the same number. So if I look at the pattern here, it was the square root, x squared, square root of x squared is x. So square root of the first minus square root of the second. Square root of 4 was 2. So square root of the first minus square root of the second. And then square root of the first plus square root of the second. Same thing on the second one. X squared minus 9. Square root minus square root, so x minus 3, and then square root plus square root, x plus 3. That pattern is going to hold for a difference of two perfect squares. It is always going to factor into the square root, so if I look at the next one, 9x squared minus 16, square root of 9 would be 3, square root of x squared would still be x, minus the square root. Square root of 16 is 4. And 3x plus 4. To check it, just FOIL it out. Let's try the next one. 16x squared minus 1. Square root of 16 would be 4x. Square root of x squared, so 4x. Square root of 1 is 1. So 4x minus 1 and 4x plus 1. Try the next one. X squared minus 25, square root of x squared is x, square root of 25 would be 5, so x minus 5 and x plus 5. These are pretty easy to see when you're missing that middle term. Look to see if it's the difference of two perfect squares. So when you're missing that middle term, check, do you have a minus? Do you have perfect squares? If you do, it's always going to factor this way. Okay, so let's look at the next one. 3x squared minus 3. I have the minus, I'm missing that middle term, but I do not have perfect squares. 3 is not a perfect square and 3 is not a perfect square. But I do have a common number that I can factor out. 3 goes into both of them. I'll be left with x squared minus 1. Well, now I have a difference of two perfect squares. X squared is a perfect square and 1 is a perfect square. So I can factor this 3. And then x minus 1, square root of x again is, or x squared again is x, plus 1. And that's it, completely factored. So hopefully you can start to see that pretty okay. That one, again, we're using kind of a logic to try to figure these out. We're going to do the same thing with the cubics. Cubics are a little bit harder to see, so it's going to take us a little bit more, but let's see. If we have x cubed minus 1, and I want to factor this. This is not a quadratic. This is a cube, or cubic I guess, with the x cubed. So it's not a quadratic, but we're still going to try to factor it into two parentheses. It's going to turn out not to be two binomials, but let's try to set it up a little bit. So, and I always should start by seeing if there's anything I can pull out. There isn't, so I'm going to go ahead and just set up two parentheses. And again, I'm going to start by just seeing what would give me the pieces I have there. So x cubed, I would need an x and an x squared. And we got cubics before when we multiply a binomial times a trinomial. It's going to turn out to be the case this time. The minus 1, what would get me the minus 1? Let's see, minus 1 and plus 1. So if I left it like this, like a binomial times a binomial, this would not FOIL out to give me the same thing. This would actually FOIL out to give me x cubed plus 1x minus 1x squared minus 1. Which is not x cubed minus 1. So I know I need something else. I need something to help cancel out these two terms, the x and the x squared term. So we're going to try to see what that could be. So we don't know what that is. I'm going to call it a blank box right now. And I'm going to multiply this out as if this was a trinomial. X squared blank box plus 1. So let's see. I'm going to first take my x and distribute that through. X cubed times, or x times blank box will be plus box x. X times plus 1 will be plus 1x. Okay, and I can kind of use some sense here. If I have an x squared in my first term, my second term here should probably have an x in it. So I'm going to go ahead and write this blank box x here as blank box x squared. Okay, so now let's take my minus 1 through. So minus 1x squared minus 1 box x minus 1 times 1 minus 1. So again, I got my x cubed there, I got my minus 1 there. I like those. I want everything else to cancel out. So I want my box x squared and my minus 1x squared to cancel. I want my 1x and my minus 1 box x to cancel. Well, the only way that both of them is going to cancel is if that box is 1. Hopefully you can see that. If I want 1x squared minus 1x squared, or box x squared and minus 1x squared to cancel, box, that has to be a 1. So I'm going to make this box a positive 1. So this is going to factor to x minus 1 x squared plus 1x plus 1. Let's do this one more time and see if we can find a pattern with it. Say I have something like x cubed plus 8. Okay, so again, I'm going to try to factor it. I'm going to write a binomial, and I'm probably going to have a trinomial, so I'm going to write a little longer parentheses. So I need, and I'm going to look to see if I can see any patterns from the previous also. If I want to get x cubed, I'm going to have x and x squared. Okay, so that looks similar to the previous. If I want to get plus 8, that means my last two numbers, last two parts are usually numbers, are going to multiply to give me the plus 8. So since in the previous one I kept the sign, I'm going to keep the sign and do a plus. And since x is a cube root of x cubed, I'm going to go ahead and do the cube root of 8 and get 2. So now what would that multiply by to give me the plus 8? Plus 4. Okay, so I have those two parts out. X cubed, x times x squared. 2 times 4 would be plus 8, so that's good. So again, I just need to figure out this middle part. Again, I'm going to put the x there and a random box so I can see what it is. Okay, so it's multiplied out. I'm going to multiply through the x. X times x squared would be x cubed. X times random box x will be plus box x squared. X times 4 would be plus 4x. And I'm going to multiply through by the plus 2. So 2 times x squared would be plus 2x squared. 2 times box x would be plus 2 box x. And 2 times 4 would be plus 8. So my x cubed is there, my plus 8 is there, which is good. I want to figure out how to get my x squareds to cancel and how to get my x's to cancel. So let's start with my x squareds. If I have box x squared plus 2x squared, if I want them to cancel, this box has to be a minus 2. I'm going to check and make sure that works for my x's. I have 4x, 2 box x, so what would happen if that box was a minus 2? That would be 2 times minus 2 would be minus 4, so they would cancel. So this box has to be a minus 2x. So this would factor 2x plus 2 times x squared minus 2x plus 4. So let's look for a pattern so we don't have to do this every time and we can just do shortcuts. So as I said before, the first binomial is really just a cube root of each term. So cube root of x cubed would give me x, cube root of minus 1 is minus 1. Cube root of x cubed is x, cube root of 8 is 2. So my first binomial is always going to be the cube root. So let's go ahead and apply that to our next one and see if we can figure out our next one. So 8x cubed minus 27. Our first binomial is going to be the cube roots. So cube root of 8 is 2. Cube root of x cubed is x. Minus 27, cube root of 27 is 3. Okay, so I got the first binomial. So second binomial. So this one, it's a little bit trickier, I guess, not much. So the first term of the second binomial, it would need to be what x times gives me that x cubed. So if this x is a cube root, then this x, the next first part of the parentheses, has to be that cube root squared. If I have this x being a cube root of x cubed, the only way I can multiply by something to get back to that x cubed is if that was this term, this x squared. So if I take this, my first term in my trinomial is going to be that first term squared, that 2x squared. So 4x squared. And you can check 2x times 4x squared would be 8x cubed. That part works. Okay, so the last number is about the same thing. In order for that 2 to become that 8, it would have to multiply by 2 squared, or 4. So I'm going to do the same thing here. 3 times what is going to give me the negative 27? The minus 3 times what is going to give me the negative 27? Times that minus 3 squared, so times positive 9. The middle term, because I need stuff to cancel out, I know it has to be the opposite sign. So if this is a minus, this has to be a plus. If it's a plus, it has to be a minus, because it needs to cancel out. So I'm going to write, for our problem over here, the 2x minus 3, I'm going to write a plus. Okay, and then how do I get that middle term? It's really, since we did these with no number in front of the x, it's a little hard to see, but it's really just multiplying the two numbers together. So x times 2 is 2x. 1 times x is 1x. So here, 3 times 2x would be 6x. Now I can check. Check and make sure it works. The first two parts should definitely. 2x times 4x squared, 8x cubed. 2x times plus 6x plus 12x squared. 2x plus 9 plus 18x is distributed through my minus 3. Minus 3 times 4x squared minus 12x squared. Good, that cancels. Minus 3 times plus 6x minus 18x. Good, that cancels. And then minus 27. So we have the right factors. So let's do this again. 27x cubed plus 125. Our binomial is going to be the cube roots. So cube root of 27 is 3x. Cube root of 125, if you don't know it, take a guess. It's probably going to be 5, and then actually cube it, make sure it works. So 3x plus 5. Our first term in our trinomial is going to be that 3x squared, so 9x squared. Our last term in our trinomial is going to be that 5 squared, so 25. In our middle term, we're going to have to change the sign, so minus, and then multiply them together, so 15x. So go ahead and distribute it, make sure it works. We'll do one last one because this is a little bit tricky. So let's just do something like 8x cubed minus 1. There, that sounds good. 8x cubed minus 1. So binomial, trinomial. First term in the binomial is going to be, well, both terms in binomial is just going to be the cube root. So 2x cube root minus 1 is minus 1. In the trinomial, first term is going to be that 2x squared, so 4x squared. Last term is going to be that minus 1 squared, so plus 1. In the middle term, we're going to change the sign and multiply the two things together. Again, you can multiply it out to check, but that should be it. Okay.